Okay, now let's see this question. This question came in GATE 2014 for 2 marks. The question is, which one of the following propositional logic formula is true when exactly two of P, Q, R are true? So they are saying that P, Q, R are there and exactly two of them have to be true. So for example, if P is true, Q is true, then R has to be false. Okay, or let's say if this is true and this is false and this is true, so exactly one, which is Q, is false and rest of them P and R are true. Or if it is false, then this is true and this is true. So when exactly two of P, Q, R are true, so here these two are true, here these two are true, here these two are true. So when exactly two of P, Q, R are true, then in all these cases, our propositional logic formula is true. Which one of them is that particular formula which is true in all these cases? Okay, that is we have to find out. Okay, so let's firstly see the first formula. So first formula is saying that P is equivalent to Q, and P is equivalent to Q can be written as PQ or not P, not Q. So when I am writing PQ, it is simply meaning P and Q, right? So this and R, okay, and or P and Q and not R. Okay. So now let's start with the first case. So in the first case, P and Q are true and R is false. So when P is true, Q is true and R is false, then this is true and true and true. All these are true. So R is false, that's why not R is true, and that's why this whole statement becomes true, and true or any statement is true. So essentially for the first case, A, B and C all are correct. D is not correct because D may not be correct because we have not checked it. But see, there is an OR sign and the right hand side is becoming true for the first case in all A, B, C. So the first case for A, B and C, all these for the first case is definitely true. Let's check for the second case. In the second case, you can understand it like, okay, R is true, and see there is symmetry between P and Q here. In A statement there is symmetry between P and Q. So P is equivalent to Q can be written as Q is equivalent to P. Here also P and Q and not R, or you can write it as Q. If you replace P by Q and Q by P, then you can understand like Q and P and not R, that is same. What my point is that rather than handling case 2 and case 3 separately, we can handle case 2 and 3 at one time only because of the symmetry of P and Q, and we can simply say that okay, R is true and one of P and Q is true. That is only sufficient to analyze both the two cases in case of one. Okay, so let's try to do that. Okay, so they are saying that R is true. R is true, so this statement is this R here, R is true and this thing is false. Since R is true, that's why not R is false, and since this is false, the and into F whatever, that entire thing is going to be false. So this entire thing is false. Okay, so if the entire statement has entire thing is false. Okay, false. So if this right hand side everything is false or this and the entire statement has to be true, then the only thing we have to do is that this entire statement must be true, So is it the case that this entire part is true with R is true and one of P and Q is true? See, if one of P and Q is true, then definitely this thing is going to be false. Why? Because this thing is true only when either P and Q both are true, or P and Q both are false, then only this is going to be true. And if this is not the case, because in this case P and Q, among P and Q only one of them is true and other one is false, in that case this thing is going definitely to be false. And if this thing is false, we can never have false and true to be true. It has to be false. So overall this thing we can understand that in all the three cases this is not true, and that's why this cannot be the answer. Let's come to B. Okay, so in B it is P equivalent to Q and it is not of that. So when you take not of that, it essentially becomes P not Q or P not PQ. So it is essentially the rest of the cases. So here what is happening is that this is going to be true only when one of them is true and another one is false. This is also symmetrical, right, as A. So let's firstly write all of them. So and R and OR, P and Q and not R. Now here also we will see that we don't need to check the first case, because first case is true in A, B, C, both cases, all the three cases. And let's try to check with case 2 and 3, and again we don't need to check case 2 and 3 separately because P and Q are symmetrical. So what we are going to do, we definitely know that this thing is false. Why? Because we have seen that when R is true, then this side is going to be false. So this entire thing has to be true for the case when R is true and one of P and Q is true. Is it the case? Let's check. So when R is true and among P and Q one of them is true and another one is false. I mean, it is true, it is false, or it is false and it is true. This is correct. See, in the formula actually it will be opposite of that. So we can see that this thing was true when both are true or both are false, and it is not of that. So you can understand that what is happening here is that if one is true and another one is false, then this thing is going to be true, and that is exactly the case here. One thing is true, another one is false, then this thing is going to be true. In this thing is going to be true, and we have already said that R is true, then this is true and true, this is going to be true, and that's why this entire thing is going to be true, and true or false is going to be true. So this entire statement is true in all the three cases. So when exactly two of PQ are true, then this thing is true. That's why this is correct, and in fact this is going to be the answer. Let's check the other two cases also, that they are not following the condition that when exactly two of them are true, then that is true, it is not happening. Let's see. Okay, firstly C. Okay, firstly see D. What is happening is that D will be definitely wrong. You see, understand why. See, when we are saying that in one of the in all the three cases it has to be correct, but what is happening in D, you firstly check case 1 and it is violating on case 1 itself. See, P is true, Q is true and R is false. If that is the case, then you see that this is true, this is true, this is true, and this is false. Okay, so if this is false, then this entire thing is true, not R is true, which means that this true and true and true, it means this whole thing is true, and there is an AND sign. So simply with respect to other three statements A, B and C, we have seen that if right part was going to be true, then we don't need to check the left part because OR was there, but here AND is there. Since AND is there, even if right part is true, for the entire statement to be true, we have to see that left part also has to be true. But we already have the condition that P should be true, Q should be true, and R should be false. If R is false and here F is there, then F and whatever is there, I don't care, this is definitely going to be false, and this is definitely going to be false. And if this is false and right side is true, false and true is going to be false. So you can understand that in case 1 itself this D is not correct, so we cannot have that as an answer. So D will also be not an answer. Let's see let's see the option C. Now in the C option they are saying that P implies Q and not R. Okay, so P implies Q can be written as not P or Q. You might be knowing, right? A implies B can be written as not A or B. So P implies Q can be written as not P or Q. And after that we are going to have and R. And after that or P and Q and not R. And we have already seen that for the first case this thing is going to be true. Let's check the second case. Now here there is not a symmetry between P and Q. P implies Q does not mean Q implies P, right? So we have to check separately for case 2 and case 3. Okay. Now you see that when case 2 and 3 we are doing, so definitely R is true, then not R is false, so this entire thing is going to be false, and that's why false and whatever is going to be false, that's why this entire thing is going to be false. So in order to this statement to be true, we have to make this thing true, because or sign is there and right side is false. That's why this entire this thing has left side has to be true, then only this entire statement can be true. Now is it possible that for this assignment where R is true, so R is true, that thing is given, R is true. Now after that, if P is true and Q is false, that is one case, and if P is false and P is false and Q is true, in that case, in both the cases we have to justify that this has to be true, which is not the case. See, in fact from implication only you can understand that if P is true and R and Q is false, then this is true. This is true. In any implication, A implication B, if this is true and this is false, then this is false. This is true, this is false, then this is false. However, if this is false and this is true, then this is true. Why? Because see, if A has happened, then B has to happen. That is the only condition. If A has not happened, and B has happened, then there is no violation of A implication B, and that's why it is correct. So in a similar fashion, when P is false and Q is true, then this is true. You can understand it like this also. So if P is false, then not P is true and Q is true. So true or true is true. So true or true is true. In that sense also you can understand it is true. So case 1 is correct, case 3 is correct, but case 2 is false. See, it is not possible to have in an implication, if A is true and then B is false, then that is not a valid implication. You can understand it like this also. If P is true, then you can understand that not P is, if P is true, then not P is false, or Q is already false. So it is false or false, and that's why it is going to be false, and true, it is going to be false. So we cannot justify the truthfulness of this in the case of the second case, and that's why we cannot say that in all the cases when exactly 2 of P, Q are true, then this is not holding. So this is also not holding. So we have already seen that we have got this answer. So we have justified after checking all the options that the only answer is B. B is correct.